Now that you know how to solve systems three different ways, actually, we learned how to solve by graphing, substitution, and elimination. What you want to be able to do now is be able to look at a system of equations and decide which one is the best. Which one is going to be the easiest or the least amount of work to get to the answer. So in general, substitution is the best method if you have at least one of your equations that's solved for a variable. So in example one, you can see that the bottom equation is already solved for x. So if you see a system of equations where one of the equations is already solved, it would be the easiest thing to do to just take y minus 4 and plug it in for x in the top equation. So let's go ahead and do that. So I'm going to do 4x, but instead of x, I'm putting what I know it's equal to, which is y minus 4. And then I'm just going to copy down the rest of the equation. So plus 3y equals negative 9. So now I have an equation that only has y. I'm going to distribute the 4. So it's going to give me 4y minus 16 plus 3y equals negative 9. 4y and 3y is 7y. And then if I add 16 to both sides, that gives me 7y equals 7. And then finally divide by divide by 7 on both sides, and I get that my y value is 1. So I know that my answer is going to be something comma 1. Now I have to take that 1 and plug it back into either one of my original equations. This one right here is going to be the best choice because it's already solved for the variable I'm solving for. So I'm going to say x equals, and then it's y minus 4, but I know that y is 1. And 1 minus 4 is negative 3. So the x coordinate of this final answer is negative 3. So that's substitution. Elimination is the best thing to do when you have equations that are both in standard form. So that means they're both an x, then a y, and then equals a number. A lot of times it's easier to do it that way versus solving the equation and then plugging it back in. So let's take a look at example 2. I can see that I have my x's, the numbers already match. They both have a coefficient of 1. The only thing that I would need to do is make one of them negative. So I'm going to choose to change the bottom equation. I'm going to take the whole thing and multiply it by negative 1. So essentially all I'm changing are the signs. So I'm going to copy down my top equation, x minus 2y equals negative 2. And then my bottom equation, all the signs are going to switch. So negative x, negative 4y, and negative 16. So now I'm going to add these two equations together. My x's cancel, which is what I wanted. That would give me negative 6y, and then that would equal negative 18. Now if I just divide by negative 6 on both sides, I get that my y value is 3. So now I have the y coordinate of my final answer. All I have to do is plug that back in to find my x. So again, I can plug it back into either of my originals. I'm going to choose to plug it into the top one. That really doesn't matter. So I'm going to have x minus 2y, but I know that y is 3, and that equals negative 2. So what I really have is x minus 6 equals negative 2. And then if I add 6 to both sides, that solves for x, which I now know is 4. So the final answer here would be 4 comma 3. For example 3, we're trying to decide which way is the best. I have both of my equations that are equal to y. They're already solved for a variable, so substitution is going to be our best bet for example 3. And these are the ones that, like, it's kind of weird. I'm just going to set the x expressions equal to each other. So what I'm doing is I'm taking 7x plus 19 and I'm plugging it in for y in the top equation. So I'm going to write 7x plus 19 equals 3x plus 11. I want to get my x's on the left side so that they stay positive. So I'll be subtracting 3x from both sides. So I would have 4x plus 19 equals 11. And then I would subtract the 19 from both sides to put my constants on the right. So that would be negative 8. And then if I divide by 4 on both sides, I would have x equals negative 2. So that's half of my answer. And then the next thing I'm going to do is plug that back in so that I can figure out what my y value is. Now I need to plug this back into, it doesn't matter which one, I'll plug it back into the top equation. So I'm going to say y equals 3x, which is negative 2, sorry, plus 11. So I would have y equals negative 6 plus 11, which is 5. So final answer is the ordered pair negative 2, comma 5. All right, so substitution was the best way there. Now I'm taking a look at example 4. This one is a total mess. So the first thing I'm going to do before we even talk about what kind of solving would be best is I'm going to get rid of the fractions, because I think the fractions make things look so much more complicated than they need to be. So remember that our trick is that we take whatever the denominator is and we multiply all of my equation by that. So I'm going to take my top equation and I'm multiplying everything by 2. So that one's going to turn into 4x equals 6 plus, and then remember this 2 and the denominator 2 cancel each other out, so I am left with just 3y. All right, so that takes care of my top equation. My bottom equation, things get kind of dicey. So I have two denominators. What we're going to do is multiply by the least common denominator. And what that means is the smallest number that I could multiply, that I could get both of those fractions to equal, both of those denominators. And the least common denominator is 10, because 10 is already 10, and I could multiply 2 by 5 and make it 10. So I'm going to take this whole bottom equation and multiply everything by 10. So what I'm going to be left with is the 10 here that I wrote, and then this 10 are going to cancel out, leaving me with just negative 1x, but I'm just going to write negative x. If I do 10 times 1/2, half of 10 is 5, so that would be plus 5y. And then 10 times negative 1 is negative 10. So now this looks a little bit more manageable. But still, we have one equation that isn't really solved for a variable, the green one, and then we have the purple one, which is in standard form. If we tried to solve for x in the green one, so what I'm going to do is, if I tried dividing everything by 4, you can see that I would still have fractions. So this would go away, and I'd have x equals, but then what I'd be left with would be messy. I'd have fractions in both of them. So for that reason, I think that it is better to do this example using elimination. So what we're going to have to do is take our green equation, and we're going to have to try to clean it up a little bit. We're going to have to take the green equation and, why isn't it erasing? Okay. We're going to take the green equation and we're going to get x and y on the same side. So I think I'm missing my y here. All right, so I'm going to take the green equation and I'm going to move the y back to the left side. So I'm going to subtract 3y from both sides. And what it's going to leave me with is 4x minus 3y, and then it's just going to equal 6. That's the only thing left on the right side. So now I can figure out what I want to do to get these things to cancel out. And I think the easiest thing to do would be to multiply the purple equation by 4. The x's are already opposite signs. And so if I multiply by 4, I'll have negative 4x plus 20y, and then it'll equal negative 40. These x's are going to cancel. This would give me 17y, and then negative 34. And then finally, I can divide by 17, and my y coordinate is negative 2. So half of my answer is done. Now I have to take that negative 2 and plug it back into either one of my two equations to get my final answer. And this is going to be a little bit weird. I'm actually going to plug it back into this thing right here. And the reason why is because x is almost solved for, so it's going to save me a little bit of work. So I have 4x equals 6 plus 3y, which is negative 2. So 4x equals 6 minus 6, which is 0. And then if you divide both sides by 4, 0 divided by 4 is 0. So final answer here would be 0, negative 2.